Hello dear students, welcome to the Royal Palace PU College online classes. So in today's session, I am going to continue the same concept about preparation of what here aldehyde and ketones. So now here we have a concept, a special methods for the preparation of ketones. Okay, so a special methods for the preparation of ketone. Okay, special method for the preparation of ketones. So now the first one method, so from acyl chloride or acyl halide, from acyl chloride. Okay, so now here in this method, so the preparation of ketones from acyl chloride. So by using acyl chloride, they are going to prepare what here ketones. So when acyl chloride react with what here dialkyl cadmium, so that gives what here ketone. So dialkyl cadmium, so which is prepared from a reaction between cadmium chloride and Grignard reagent. So after preparing this dialkyl cadmium, so that dialkyl cadmium react with what here acyl chloride, so that gives what here a ketone product. So the thing is, from acyl chloride, so they are going to prepare what here ketone. Okay, I will write one example, general reaction. So dialkyl cadmium, so first of all I will write the preparation of dialkyl cadmium. So after that, so we can move for the preparation of the ketone by using what here acyl chloride. So now I will write here preparation of dialkyl cadmium. So after getting this dialkyl cadmium, then again we are going to prepare what here ketone by using dialkyl cadmium and acyl chloride. Now before that we need what here dialkyl cadmium for the preparation of ketones. So the preparation first, the thing is, first we have to prepare what here dialkyl cadmium. So dialkyl cadmium, which is prepared by the reaction between cadmium chloride and Grignard reagent. So we know the general formula for the Grignard reagent is RMgX. Okay, so now here there is a formation of what here dialkyl cadmium. So for that we need what here dialkyl, two alkyl groups. So hence I have written here 2. Okay, so we required what here dialkyl, 2 alkyl groups. So for that reason I have written here 2. Okay, so there is a formation of what here dialkyl cadmium. So this is an dialkyl cadmium, and with liberation of what here cadmium chloride. Okay, so cadmium chloride. Now here, so cadmium chloride, here after formation of this dialkyl cadmium, so remaining thing what here, so the here 2Cl MgX. Okay, 2Cl MgX. See here, cadmium chloride react with what here Grignard reagent, will get what here dialkyl cadmium with liberation of, with loss of what here 2Cl, here 2Cl are there and 2 MgX. So hence I have written here directly 2Cl MgX. So here after formation of this dialkyl cadmium, so that is react with what here acyl chloride. Okay, so first of all, first you have to prepare what here dialkyl cadmium. Now preparation of ketone from acyl chloride is, so now I will write the reaction for the preparation of ketone from acyl chloride. So acyl chloride formula you know that, so this is a general formula for the acyl chloride. So this is a reaction. Okay, so acyl chloride react with dialkyl cadmium. Okay, so now here, so after this there is a formation of what here a ketone will be formed. So for that you need to what here, you have to take what here 2 moles of what here acyl chloride. Now here formation of what here ketone, so ketone, that is RC double bond OR. So this is a ketone, and with the loss of what here cadmium chloride CdCl2. Now here 2 Cl's are there, and this side we have 1 Cd is there, cadmium is there, hence here loss of what here CdCl2, cadmium chloride, and formation of what here ketone. So this is the method, which is this one reaction method used to prepare what here ketone from acyl chloride by using dialkyl cadmium. Dialkyl cadmium. So dialkyl cadmium, which is prepared by the reaction between cadmium chloride and Grignard reagent. So this is an Grignard reagent, general formula RMgX. Okay. So after when cadmium chloride react with Grignard reagent, there is a formation of what here dialkyl cadmium. So after getting dialkyl cadmium, acyl chloride, so this is the reaction which is used to prepare ketone. Acyl chloride react with dialkyl cadmium, so formation of what here ketone, formation of ketone. Okay. So this is one method for which is used to prepare what here ketone from acyl chloride react with what here cadmium chloride. So next one reaction from nitriles, from nitriles. So method which is used to prepare what here ketone from nitriles. So let us, I will take one example. So nitriles, that is react with what here Grignard reagent, and that will undergo acid hydrolysis, that use what here ketone. So now I will take directly one example, nitriles, CH3 C triple bond N, ethene nitriles. Okay. So when it react with phenyl magnesium bromide, phenyl magnesium bromide. So this is an Grignard reagent, phenyl magnesium bromide, and this is an ethene nitrile. So generally nitriles react with a Grignard reagent, which gives an additional product, intermediate product. So after this, that intermediate product, that will undergo hydrolysis, acid hydrolysis, that gives what here a ketone. See here. Now after this, what happened? An intermediate product will be formed. So like this, CH3 C, then I will write here double bond N MgBr. Okay. Now this side here we have single bond C6H5. Now, so this is an R part, R minus part. Consider the general formula, we have RMgX. So this is a Grignard reagent. Now here this part, minus part, and MgX it is an plus part. Now this minus part, that is C6H5 minus, which will attack here. Okay. So after this, this triple bond, one electron that will shift to here. The triple bond, this bond shift to here, so that will become sort of CH3 single bond C double bond N minus. So after this N minus, which attract what here positive part of this Grignard reagent, that is N minus, and here MgX is there. Okay. So this one CH3 single bond C double bond N minus part is there, so it will attract to the plus part of this Grignard reagent, that is MgBr. So this will attack here. This is an intermediate product. This is an intermediate product. So which will undergo hydrolysis, acid hydrolysis, H2O, acid hydrolysis in presence of acid. So here hydrolysis can be takes place. So this part we have O part, and here this side we have H2 part. Okay. So now here again this will undergo one more hydrolysis, 2 moles of hydrolysis. So this part here H part, and here OH part. Okay. Hydrolysis 2H2O. Okay. Here one H2O part is there. Oxygen add to this part, H2 add to this part. Again this bond will undergo breakdown. H part adds this side, OH part this side. Now the product is what here? So I will write here product CH3 C double bond O. This side CH3CO is there. Then one more product, that is C6H5. So this one CH3 C double bond O, C6H5 plus NH is there and H2 is there, totally NH3 ammonia, plus one more part, that is MgBrOH. So this one MgBrOH. So here there is a formation of an ketone. The name of the product is phenyl ethanone. Okay. So this is the a method of the preparation of what here ketones. So from acyl chloride, from nitriles. Now let us, we will move for the next one concept, that is physical properties. So physical properties, the first one concept, that is physical state. So at room temperature, methanol, which is a gas, methanol is gas, and ethanol is liquid, sorry, volatile liquid. Ethanol is volatile liquid. So remaining all aldehyde and ketones are the liquid or solid. So this is the physical state of what here? Aldehydes and ketones. The first thing, physical state of the aldehyde and ketones. The methanol at room temperature, the methanol is gases. So whereas the ethanol is volatile liquid, and other aldehyde and ketones at room temperature, they are the solid or liquids. So this is the first physical property, that is physical state. So let us, we will move for the next one, second one property, that is boiling point. The boiling point of this aldehyde and ketones are higher than ethers and other hydrocarbons. Ethers and hydrocarbons, okay, ethers and hydrocarbons. So this is because of what here? Dipole-dipole interaction. Dipole-dipole interaction existence. Due to dipole-dipole interaction existence, the boiling point of aldehyde and ketones are higher than the ethers and hydrocarbons having comparable masses. So here the boiling point of aldehyde and ketones are higher than the comparable masses of hydrocarbons and ether because of what is dipole-dipole interaction. So whereas the boiling point of aldehyde and ketones are lower than the alcohols. So because of what here? Absence of hydrogen bonding. So in case of alcohol, so we are going to observe what here? Hydrogen bonding. So but in case of aldehyde and ketones, there is an absence of hydrogen bonding, hence the aldehyde ketones have what here? Less boiling point compared to what here? Alcohol. So less boiling point compared to the alcohols. Aldehyde and ketones have what here? Less boiling point compared to alcohols due to absence of what here? Hydrogen bonding. So whereas the boiling point of aldehyde and ketones are higher in compared to what here? Hydrocarbons and ether due to what here? Dipole-dipole interaction. So next one, solubility. Next one property, that is solubility. So this is another one physical properties, that is solubility. So lower members, they are miscible in water. So as increase in the length of the chain, size of the compound, that means higher members, the solubility decreases due to increase in the size of the alkyl group. So alkyl groups are hydrophobic in nature, water heating character. So hence as increase in the size of the alkyl group, number of alkyl groups, so what happen? The solubility becomes what here? Decreases. But whereas lower members of the aldehyde and ketones like methanol, ethanol, propanol, they are the miscible in water, whereas the higher member as increase in the size of the aldehyde and ketone, I mean higher members, the solubility decreases due to increase in the size of the alkyl group. Alkyl group is an hydrophobic in nature, water heating character, hence the solubility in case of what here? Higher member decreases, whereas in case of lower member the solubility is more. Okay. So next one, odor. Lower member of aldehyde having what here? Sharp pungent odor. They possess what here? Sharp pungent odor. But as increase in the size of the member, higher member, as increase in the size of the aldehyde and ketones, the size, higher member increases, the pungent odor becomes what here? Less, and that will becomes what here? More fragrance. So lower members having what here? Sharp pungent odor, whereas the as increase in the size of the size of the compound, the pungent smell, that will becomes what here? That will becomes less pungent and more fragrance. Okay. So these are the physical properties of the aldehydes and ketones. Okay. So there are mainly 4 physical properties are there.
that is physical state, lower members like ethanol, that is gaseous in nature, ethanol, that is volatile liquid at room temperature. So whereas other aldehyde and ketones at room temperature, they are the solids and liquids. Now boiling point, the boiling point of aldehyde and ketones are the lower than the alcohol because of absence of hydrogen bonding. So whereas the aldehyde and ketones having more boiling point compared to ethers and hydrocarbons because of what here dipole-dipole interaction. And the solubility, lower member are easily soluble, immiscible, miscible in water. As increasing the size, they are becomes what here immiscible. Okay, the solubility decreases due to increase in the size of the alkyl group. Alkyl groups are what here hydrophobic in nature, water heating. Odors, lower members they have what here pungent odor. As increasing the size, higher members they will possess what here fragrant, more fragrance. Okay, so these are the physical properties. So next one, chemical properties. Chemical properties. Okay, so in that first one, nucleophilic addition reaction. Nucleophilic addition reaction. Addition reaction. Okay, so already we know that in case of aldehyde and ketone, there is a presence of what here carbonyl functional group. Carbonyl functional group. And we know that the oxygen is what here more electronegative atom. So electronegativity means they have tendency to attract shared pair of electron towards itself. Here the oxygen is more electronegative atom, hence it will withdraw electron towards itself, that will take what here partial negative charge. Okay, so whereas this carbon, it is an less electronegative compared to this oxygen atom, hence that will take what here plus charge, because it readily accepts the electron, it readily loses their electrons, hence they will take what here partial. Oxygen, that will take what here partial negative charge, this carbon, that will take what here partial positive charge. So due to this carbon which is act as an electrophile. So electrophile means electron deficient species. Now this carbon is somewhat having what here plus charge, that indicates there is a deficiency of electron. So for that reason the nucleophile will be attacked to this carbonyl carbon, because this carbon having what here less electron density, electron deficiency is there. So this nucleophile means electron rich species. So the nucleophile which will attack to the electrophilic carbon only, because this is an electron rich species and here the electron deficiency is there. For that reason this nucleophile which will attack to the carbonyl carbon which is electrophilic in nature. So in such a way that, so exactly perpendicular to the plane of the paper or plane, exactly perpendicular to the plane. So forming what here, so here an intermediate will be formed. So intermediate, so I will write here intermediate will be formed. So oxygen, because this electron shift here and here attack of what here nucleophile. So this side nucleophile will attack, so this electron shift here, oxygen that will take what here electron towards itself, and there is a formation of what here alkoxide ion. So later on which abstract a proton from the reaction medium, so forming a product, so product Nu, so here OH. So this is the mechanism of nucleophilic addition reaction. The nucleophile which will attack to the carbonyl carbon only, because this carbonyl carbon is, it shows what here electrophilic in nature due to presence of this oxygen. Oxygen is more electronegative atom which will withdraw electron towards itself. So for that here there is a formation of a partial positive charge here, this oxygen that will take what a partial negative charge. Hence the nucleophile which is electron rich species which will attack to this carbon atom only, because electron deficiency is there. So that is perpendicular to the plane and forming an alkoxide ion. So later on, so which will abstract a proton from the reaction medium forming an product. Okay. So this is a general mechanism of what here nucleophilic addition reaction. Here the carbon atom having sp2 hybridization. So after this carbon undergo what here that undergo sp3 hybridization. So here hybridization also changes from sp2 to sp3. The structure also changes from trigonal, planar to tetrahedral. So this is an a general mechanism of what here nucleophilic addition reaction. So let us, I will take one particular example, nucleophilic addition reaction. For the nucleophilic addition reaction, I will take one general reaction, addition of hydrogen cyanide. Addition of hydrogen cyanide. Okay. So addition of hydrogen cyanide. So let us, I will take a general reaction for aldehyde and ketone. So this is, consider this is a carbonyl group. Here the addition of hydrogen cyanide can be takes place. Now I will write cyanide, this is an nucleophile. So hydrogen cyanide react with, in presence of base. So there is a formation of Cn minus plus H2. So now this Cn minus, it is act as a nucleophile. So that Cn minus, this is a nucleophile which will attack to this carbonyl carbon, because this is an electron rich species. This is a nucleophile. So that will attack to the carbonyl carbon only, because it is an, it will show what is electrophilic in nature, because of presence of this oxygen, it is more electronegative atom which withdraw electron towards itself, shared pair of electron towards itself. So this will, this carbon that will take what is plus charge, partial plus charge, and this one that will take what is partial minus charge. Hence here on the top of the carbon atom there is a less electron density. For that reason here the nucleophile will be attacked. Okay. So I will write this Cn, nucleophile. So now what happened? The nucleophile which is exactly attack to the carbon in perpendicular, exactly perpendicular. So this is an Cn, I will write here Cn, and this is carbon as it is, and again we have here O minus, alkoxide ions. So which will abstract a proton, and there is a formation of product. This is Cn as it is, and now here this will becomes the O minus. So this will abstract this proton. So there is a formation of what here? Cyanohydrin. Cyanohydrin. So this is the one example for the nucleophilic addition reaction. Addition of hydrogen cyanide to the carbonyl compound. So now let us, I will take another one example. Addition of sodium bisulfite. Okay. Addition of sodium bisulfite, NaHSO3, sodium bisulfite, NaHSO3. So now here carbonyl, this group aldehyde or ketones, here the nucleophile is what here? HSO3 minus. HSO3 minus. Okay. So again here Na plus, HSO3 minus. So HSO3 minus, which is act as a nucleophile which will attack to the carbonyl carbon. So again this oxygen which will withdraw electron towards itself. There is a formation of an intermediate product. Okay. I will write here as it is. O minus, and here HSO3. Okay. Or SO3H. Now here what happened? Proton exchange can be takes place. Proton transfer. So that will becomes, this proton comes here as it is. So OH, and this will becomes what here? SO3 minus. So after this addition of this Na plus, so the NaHSO3 that will dissociated as Na plus, then what here? HSO3 minus. So this is a nucleophile which will attack to the carbonyl carbon atoms, and here the exchange of proton transfer can be takes place from this proton. So this will, this oxygen which will abstract this proton transfer can be takes place, exchange can be takes place. So after this SO3 minus, that will abstract this Na plus. The product is what here? SO3 Na, here single bond OH. So this is the second method for the preparation of what here? Chemical properties, nucleophilic addition reactions. These are the examples. Nucleophilic addition reaction, addition of hydrogen cyanide, this one example, and addition of what here? Sodium bisulfite. Okay. So this is the a reaction mechanism for the nucleophilic addition reactions. Okay. So next one concept, addition of Grignard reagent. So now Grignard reagent, already we know the general formula RMGX. So which will adds to the carbonyl group.
Okay, so now already we know that this is a minus part, R minus, and this is a plus part. So this will attack to this carbonyl carbon, because already we know that the carbonyl carbon is an electrophilic in nature. Hence, so this will attack here, and this oxygen which will draw electron towards itself. So we know that the oxygen that will take whatever minus charge after addition of this R group. So we know that this is a plus part, MgX, this is a plus part. So which will add to this minus part of the oxygen atom. So hence the reaction is OMgX. So because the oxygen here after attacking this R group to the carbon, the oxygen that will take whatever minus charge, and we know this one R minus, it is a minus part, so this is plus part. So hence this plus part adds to this oxygen. So the product is, intermediate product is this one. So after this will undergo hydrolysis. Hydrolysis, this side we have H part and here we have OH part. Now the product is what here? Alcohol. That is what here? Alcohol. Okay. So here RCOH is there. So that is what here? Alcohol. So let us, I will take a general reaction. Now general reaction, I will take one example. Formaldehyde. Formaldehyde. So when react with what here? Grignard reagent. General reaction RMgX. So we know that this is a minus part which will attack here. So this oxygen that will take what here? Minus charge. So the intermediate product is RCOMgX, because this is a plus part which adds here minus 2. Sorry, this is a plus part which is add to this minus part of this oxygen atoms. So now here H, and this is an R group. So which on hydrolysis HOH, we will get what here? R HOH, and this is RH. That means RCH2OH. So here formation of what here? Primary alcohol. Primary alcohol. Primary alcohol. Now the remaining part MgX OH minus. So if you take the other aldehydes except this is methanol, except methanol, if you take the other aldehydes, you will get what here? Secondary alcohols. That means only the methanol, formaldehyde, that use what here? Primary alcohol. Other aldehyde use what here? Secondary alcohol. And if you take the ketone, that use what here? Tertiary alcohol. So this is the reactions which concern to what here? Addition of Grignard reagent to the carbonyl group. So after addition of this Grignard reagent to the carbonyl group, we will get what here? Alcohols. So only methanol gives what here? Primary alcohol. Formaldehyde, methanol, that gives what here? Primary alcohol. Other aldehyde that use what here? A secondary alcohol. And if you take the ketones, you will get what here? Tertiary alcohol. Okay. So these are the reactions, examples for the nucleophilic addition reaction. Now I will stop here. We will continue in next class. Thank you.